Hi, my name's Steve Norman and I'm a renewables consultant working at the Met Office. It's my pleasure to be here with Wind Power Monthly hosting this webcast on the subject of next generation wind assessment techniques. The objective of the Met Office at this webcast is to really highlight the benefits to the industry that can accrue from adopting new standards, new technologies, new science as they emerge to increase the confidence, basically, especially in the wind assessments, which, as you will hear, is so fundamental to the investors, turbine manufacturers and operators, developers alike. And to that end, we've invited three distinguished gentlemen from the industry to join us. Ian Burrow from NatWest, who's representing really the investor community. Charles Connor from Temporis Winds, who's a sort of dual role of equity investor and developer. And Julian Martin, who's representing the turbine manufacturer community, whose interests are slightly different. So hopefully you will have a cross-section of discussion which will be representative of all aspects of this exciting industry. Yes, well, one of the issues is in terms of looking back for such a young industry, and we've only been going a relatively few years. There is no wind farm currently that's actually completed its whole life cycle of 20 or so years. So we've only got a very few years to go on. And technology and science and the commercial practice has moved on substantially during the last few years, but I think the way we've assessed wind hasn't. We still seem to be stuck in the same traditional kind of rut now as we were, say, 5 years ago in terms of measuring wind and predicting wind for a particular site.
And what we're seeing in the medium wind sector is rapid deployment of turbines, and a lot of that is based on taking data from wind maps and wind databases. And really, in our sector, we're looking for something better than that because we've got government support in this sector now through the feed-in tariffs. And we're looking at quite short review cycles on that tariff structure and downward pressure and digression on tariff rates. So what we've had is a relatively fast way of getting data, but with inherent inaccuracies with the wind databases. And we really need to improve the standards within the sector, but we don't want to be incurring the cost and the time involved in long-term on-site wind measurements necessarily.
So you need the very best wind assessment you can out of the box, basically.
Yes, because the cost can be a significant part of the wind project, and the time involved could see you into another review cycle on one of the major considerations for support for your scheme.
And that's where we are from a bank really point of view. We've tried to professionalise the industry in terms of our help and support and advice to the customers that we get involved with. Done a lot of training, a lot of accreditation program, etc. So on one hand, we've got all the skills and the knowledge and the expertise, but the thing that we were lacking was the accuracy of the actual data compared to the desktop analysis that were historically been done in the industry. So hence why we're trying to get a lot more kind of accurate and pinpoint kind of measurements to ensure at the end of the day the return that our customers are seeing is as accurate as possible. Whereas historically, when we met you down in Exeter, Stephen, some of the examples that we brought with us differed around about 1 or 2 meters per second on the actual accuracy levels, which when you multiply that up in terms of the financial returns from a wind project, would make a lot of difference to the actual serviceability of a loan, and also in terms of the actual customer expectations as well. So we need to be really as professional in the actual wind assessment and the accuracy of the wind speed as we are as the actual help, knowledge and support that we give the customers.
In terms of the financial structure of your but you're in it for the long term, of course, aren't you? You're in it for the 10, 15 years or so you need to make sure that all the numbers add up in the in the long term.
Yeah, it's about treating customers fairly as well, because we wouldn't want to work with them on a particular project we know what the costs are, we know what the actual kind of build project costs are and the feasibility studies, but the one thing that in my eyes was lacking in terms of its professionalism was the actual wind speed. So for us it's a major part of our overall kind of business planning and business assessment tool.
Yeah, I think the point Julian makes about the ability to have some information out of the box is an important one. And traditionally, and even still today, most people in the industry, as their first cut analysis, use the Knowable database, which was developed back in the 90s, and will have routinely errors of up to a meter a second or more, which is makes the analysis perfectly irrelevant. 1 meter a second is a massive error, and a project will be a very, very good project at 7 meters a second and will be an absolute non-starter at 6 meters per second. So I think the industry has, certainly at the early stage analysis, has been relying to a great extent on a tool that's not fit for purpose at all. And to get usable data has required at least a year of on-site wind measurement, then going to the Met Office and buying usually not enough data because it's too expensive.
Yes, indeed.
People often buy 10 years of data because 20 years cost twice as much or whatever. And that's been a big problem as well. So we haven't done a very good job at the initial level, and in many cases haven't done a great job at the even more detailed level.
And that's exactly what I'm saying. When we went down to see Stephen, we actually took a real life case example with us in terms of the actual pinpoint of where the actual proposed medium turbine was going to be sited. And the Knowable and Carbon Trust database was showing 6.4 meters per second. And then when we ran the model through the virtual Mast kind of plan that we talked with Stephen, the actual was 5.2. The actual wind speed was 5.2. So if you magnified that 1.2 difference up in terms of end kind of financial modelling, business planning, cash flow forecast, it will make a lot of difference to our assessment of the project and ultimately the customer returns.
I can tell you that going from 6.4 to 5.2 would probably knock your revenues down by 30%.
Yeah, good.
The 30% is probably low. If you see your wind speed go from 6.4 to 5.2 meters per second, I would say it's 30 to 40% decrease in revenues, and it's a huge impact on your project. And I don't think almost anyone would do a project with 5.2 meter a second wind.
No.
Whereas 6.4 meter a second wind might work, might not work, depending on the site.
Well, I'd just like to highlight that, just build on that point that Charles has made, because looking back 2 or 3 years when the Met Office first started to undertake much more focused research and development into understanding the behaviour of wind, it was clear to us then that the sensitivity of both the power and the financial returns for any particular wind operation, wind site, was indeed very sensitive to the accuracy of the underlying wind assessment. And I can name 101 different approaches that I've seen in the market for undertaking such assessments, both at the large scale end of the wind market and at the very smaller scale markets. The use of all sorts of different kinds of public and other data, the way the data is combined, the use of on-site data. People will actually spend a lot on a mast and put the mast up and take 6 months worth of measurement and just use that particular output, whatever it might be, for the last 6 months as the truth for the longer term.
Yeah.
If you've read a lot of wind yield analyses, you will see that the engineers analyzing the data often struggle to find good reference data. There'll be some reference data 8 kilometers away at a different elevation, and like you said, a 10-meter mast, but it's missing some data, or that it appears to be wrong, and often the on-site data appears to be wrong. And so the analysis often, the people who analyze the data often liberally remove data when it doesn't seem right. And so I'm always a bit suspicious when I read these reports, because they've taken this reference data and that reference data, but they've removed something that didn't quite fit, and it's quite subjective and worrisome
And inconsistent.
Yeah.
between one exercise and the next,
Oh, yes.
perhaps.
And one of the key questions we're asking now, Stephen, is the fact that we are asking the original data source origin of the actual wind speed. You know, what kind of, where was it coming from? No eyeball carbon trust. You know, is it kind of just a mast that's been up for, you know, a certain period of time? So one of the key questions we're asking now is the actual origin of the data of the wind speed, because again, linking back to the question that you mentioned, Charles, it's very key for the actual overall outturn of the project in terms of the accuracy of the data.
I think as well the site complexity as well comes into play, and if you're just using data from a wind atlas, are you really getting the true complexity of that site as well, built in terms of obstacles and surface roughness and so on? So there are questions about that as well.
Well, you're particularly concerned, I guess, because it's not just wind speed, long-term wind speed that's at stake here. We're talking about the turbulence behaviour at any particular site, the wind shears, the maximum kind of gusting that might take place, short-term gust,
the shape
and
of the distribution curve.
the shape
is
of
very important.
Absolutely.
your turbine equipment has to be able to withstand all that.
It has to be able to
you underwrite that, presumably.
Yeah, it has to be able to withstand that, and also on the back of that information, the manufacturer is putting forward their warranty for the equipment in that site as well.
Indeed.
So it's very important to get it as accurate as
It was
possible.
acutely magnified by the recent high winds, storms over the UK in December and January, where a lot of the turbine populace didn't quite make it through those storms. Maybe it was an adverse event, but maybe there are also some turbines that were there that shouldn't be there.
As an equity investor in wind projects, typically pre-construction, we are particularly sensitive to the financial, the wind assumptions. Where the equity holder gets his or her return after the debt is paid back, after the operating expenses are paid, after the royalty is paid to the landowner. So if we miss the wind by, say, if we miss the revenue line by 20%, chances are the debt will still get paid back. The landowner will get a slightly lower royalty, maybe not, depending on the terms. The operating costs will still be paid. The equity holder eats it all. So we are particularly sensitive to this, and I think the experience we've had in the UK and Europe in the last couple of years with very low wind speeds have hit equity investors very hard. And I do think that the hurdle rates for equity investors are going up. People are looking for higher returns than maybe they were a few years ago on pre-construction assets. And conversely, perhaps many investors are showing a real preference for assets that have been up and running for a few years. And so you can, in a way, it's if you get it right, it's quite advantageous as an equity investor, because you can invest at perhaps a higher rate of return, and then sell after it's up and running at quite a lower rate of return and get a big uplift in value. But it's a very risky game for an equity investor in a wind farm, the pre-construction.
For us as well, managing the risk is an important part of our overall kind of project finance, and what we're doing, Charles, we're doing a lot of assessments in terms of the projects that have been funded through the desktop kind of analysis on wind assessment, and as we are insisting now on the actual more accuracy of the Mast and the actual data, then hopefully, you know, the actual returns that we are seeing will be a lot more akin to what we expect from the outset. So we're trying to, again, all the time to improve what we're doing in terms of making sure that the customer is not feeling let down or disappointed in terms of his returns from his wind farm project.
In the financial analysis we do on these investments, we're looking at revenues, we're looking at landowner royalty, we're looking at operating costs, we're looking at bank debt servicing. And we can get the operating costs very close. We typically enter into 5-year warranty and operating agreements with the manufacturer. So we're very good on getting our operating costs right, no huddle. The royalty is very easy. It's usually a percentage or a fixed amount. We get that right. We certainly get our projection of the debt service right. We know exactly what it is. And so everything depends on this one big number, which is revenue, which depends on wind speed. Yeah. And I feel like we do so much work on the analysis of all these other components, and we get them right. And I think we spend so much time because they're easier to analyze. And the one that's really tough to analyze, which is the wind, we often don't analyze that enough. We accept a number. We say, okay, the wind's 7.2 meters a second at hub height. And if we're wrong even by two-tenths of a meter a second, which doesn't seem like much, go from 7.2 to 7, we might have 5-6% reduction in our revenue, which will, to the equity holder, is a big number, because off that 90, we've lost 5% of our revenue. Our operating expenses have stayed the same.
Yeah.
Our debt service has stayed the same. Our royalty has stayed largely the same. So that 5% decrease in revenues might mean a 20% decrease or a 30% decrease in the dividends to the equity holder. So I don't think we've done enough work on the most important number, which is the wind speed, and we haven't done it well enough.
And that's why we as a bank, we're working closely with Stephen and his team in the Met Office to ensure that we've got those component parts right. We know what the costings are. We know what the serviceability is in terms of the loan repayments. The key factor is the income that comes into the project at the top end. So again, going forward, I'm confident that when we start working closer with Stephen and his team in terms of the actual reports, we are doing as good a job as we possibly can to ensure that project is given a true kind of reflection of its wind speeds.
Well, and there's two levels we're talking about. People who fund their own project on the back of the level, and then professional investors who do all the work.
Yeah.
We've never invested in a wind farm in the Ventus funds without having gone through the whole wind measurement, the MCP, measure, correlate, predict methodology, hired the top engineering firms to give us wind estimates, and even still we're not we haven't been happy with the results. And we don't know. I don't think anyone in the industry knows if that's because the methodology is bad, or if it's because we had two very bad wind years in 2009, 2010. But we do know that there was the reference data. The 10 years of reference data that was normally being used for wind reports in the 2004, 5, 6 time frame was based on a data set that included pretty much all of the 90s, from the early 90s to the... And apparently 93, 94, 95 were extremely windy years.
Yes,
so we were using, I think, too small a data set, a 10-year data set, and it included a very, very windy period. So I think everyone in the industry... I don't know everyone, but I think people in the industry largely think we have been relying on estimates that were too high, and I think that's another, part of the technology that the Met Office has developed is looking at much longer data sets, trying to develop a 25-year a picture of the wind over 25 years. Because really, when we're predicting wind for the future, we're not really predicting the wind for the future. We're asking what was the wind in the past. And the longer data set we can have for answering that question, what was the wind in the past, I think the better chance there is that it's going to be similar to what's going to happen in the future. But to say the last 10 years are going to be like the next 10 years, it was probably never a very good assumption.
One of the areas of research and development in this area that the Met Office is undertaking is in a solution called the virtual Mast, which you'll hear talked about in this discussion. It's basically a model-based approach to assessing wind techniques, wind assessment, which works closely with our global weather forecast model, takes all the data from that and all the observation data from that model and literally downscales it to a specified site and turbine height. So really it's an alternative way and a new way of assessing wind very accurately, very quickly and cost effectively. So building on all the discussion that's just taking place, the issues, the challenges that are faced by all my colleagues in their respective parts of the industry, the goal of the Met Office is threefold. Basically to help to make the wind assessments more accurate, more consistent between one project and the next, and also bearing in mind the advent that we now have a huge variety of scale of wind project in the UK and globally, to make whatever we do scalable between the very large projects and the smaller wind projects.
I think for the medium wind industry, Stephen, the virtual Mast solution is one way of reducing the cost of the development phase of the project. We can get a much more accurate assessment of the site in a much shorter time frame, weeks rather than months, meaning that we can have an accurate and a standard methodology of site assessment. And that standard methodology meets the international standards, the IEC standards, which are the standards that that's being undertaken in the industry by Renewable UK and other organisations in the sector are looking to achieve as a minimum standard.
Since May, since we launched our Renewable Energy Fund at NatWest and Royal Bank Scotland Group, we've done a lot of work, Stephen, on the professionalisation of the industry in terms of training 307 specialists across the country, UK-wide. So I was happy with the building blocks in terms of the assessments on site, assessments of the actual project in totality. So for me, the solution to produce and have produced a virtual MetMast report for the projects that we're involved with, for me, closes that gap and is the missing piece of the jigsaw for me, because without doubt, one of the main things for us is two or threefold. Is making sure that the customer is happy with the actual overall kind of returns that he's getting. B, that we help and support those customers, but also C, that we're making sure that as Julian says, that the turnaround times in terms of some of the quite quick wins that we're wanting to happen with the customer, quite short timescales. The actual virtual MetMast for me gives you quite a 28-day turnaround, a vastly reduced fee for the customer and cost. So for me, it's a win-win for everybody, and it just helps us move forward in terms of our offering to the customer.
We, in the Ventures Funds, look at slightly bigger projects, maybe than the ones that Julian, you and Ian are financing, or Julian, you're working on. But I think the virtual MetMast is a very important tool early in the planning process. It's certainly not unusual to spend several £100,000 on a modest wind farm to get it developed, and to spend a few £1,000s up front to get a better picture of the wind is very meaningful. I'm still quite interested in on-site wind measurement. I think that certainly for medium wind farms and above, you want to combine on-site wind measurement with long-term data, whether that's from the virtual MetMast or using the traditional methods, or both. But that's even for the small projects. I think that you have cases where maybe the virtual MetMast shows you it's a low complexity site. It looks like the wind's very strong. You have a lot of margin for error. But there's other projects where you don't have as much margin for error. So I think that combining the virtual MetMast with on-site measurement is going to be an important way forward. And I think if we could get some technology around on-site measurement that was a little less expensive, figure out a way to combine the virtual MetMast with, say, 10-meter data that we could perhaps get in a cheaper manner. That's going to be important.
How I want to take the offering forward is that we've worked with Stephen and to do a kind of a three-stage process, Charles, in terms of depending on what size of wind project you're looking at. So we're working with a virtual MetMast Lite kind of report that looks after the small wind, covering Julian's kind of medium wind. We've got a kind of medium stroke high report. And then the larger projects that we're involved with, we're actually doing a mix and match, as you say, in terms of the actual full-blown MetMast kind of report, as well as on-site data as well. So we're trying to gauge the size of the project in terms of the actual kind of analysis that we do, but at the same time, the bedrock and foundation is always geared upon the Met Office kind of stats, which are more accurate, rather than the actual knowable database that we've historically, gone with, really.
Can I just clarify what you're talking about there is we refer to as Virtual MetMast Plus, which is this ability to mix in varying periods of site data with the underlying long-term virtual MetMast projections. The exciting thing about that is we're just about to announce the results of research that we've undertaken into the increased certainty that we can get by adding in those varying periods of data from 3 months, 6 months to a year plus. So we can present you, the investors, the equipment providers, with the wind reports together with the certainty, the level of certainty, and you can decide what certainty you need and therefore looking backwards, what kind of data you need to collect, or your clients need to collect. Quite often, as you know, your clients will come to you and say, well, exactly how much data do I need
Yeah, exactly.
from various sites? Now we'll be able to tell them, and you can pay your money basically and take your choice in terms of the risk.
So that's a question I'd like to ask
level.
you, Stephen, in terms of we sensitise some of the information that we receive in terms of some of the wind speed data and the feed-in tariff returns. What kind of accuracy levels, can you commit to in terms of your virtual MetMast really for an investor or a bank's point of view? Because for me, yes, we'll get a figure from you in terms of the Met Office, in terms of how what wind speed is on a particular site in terms of longitude and latitude grid points, for example. But how accurate can your virtual MetMast be for a bank or an investor?
That will depend on the nature of the site. I think you were talking about the difference between complex sites, complex topographies, whether it's urban, whether it's open farmland or something. So the certainty, the accuracy will depend on the nature of the land. Offshore at the moment, we're working within 0.1 metre per second through the verification that we've carried out.
Yeah.
It's not unusual onshore for us to be within 0.3 metres per second, for instance, and that's just out of the box. Then we can mix in varying periods of 3 months, and 3 months, even 3 months worth of data will improve that figure dramatically.
I think you mentioned, Stephen, site complexity. That's important. So where you do have the complex sites, particularly you're going to find that with the medium scale of turbine, it's likely to be closer to farms, buildings, and so on. You have got that capability to take data that's been measured on site for a short period of time, which still won't impact the build out period.
That's right.
And incorporate it with the virtual MetMast in your VMM Plus.
That's right.
To give a more accurate solution. I think that's important going forward for complex sites.
Julian, do you feel that in the industry as a whole we can move, or the manufacturers can move to being their source of data, Met Office, a Met Office equivalent, etc.? Because I'm still worried that yes, your company look forward looking and wanting to bring everybody up to a certain standard, which is great, but I'm still concerned that other people in the industry won't be as as professional or as proactive as you guys. So how can we all make the industry move towards a more accurate data assessment from day one?
Yeah, well, I've been working in a group at Renewable UK, which if you look at the numbers of manufacturers represented in that group, you've probably got half to 2/3 of the world's medium wind manufacturers, and there is a commitment there to bring in a minimum standard for site assessment as part of that work. So when you do have so many manufacturers setting that as the commercial benchmark, then the hope would be that the others who are maybe not involved at the moment would move along to that standard as well. But equally, it's not just the manufacturers, it's the installers as well. And we need to make sure that the installer companies and the advisors and the consultants in the sector are at least working at a minimum standard.
In all this modeling, we're dealing with uncertainty, and we just need to be better. And you need to, in your analysis, always put in some margin for error, because you're going to have good years and you're going to have bad years. And we've seen that a bad year can be quite well below a good year. In the last couple of years, we've been 20-30% below the long-term average.
And that's exactly what we do in our model. We actually sensitise. We get the wind speed accuracy data from Stephen. We know what that will produce from a feed-in tariff income point of view, but we also sensitise that down by about 25-20%, just to ensure that there's sufficient headroom for that customer to comfortably afford the repayment of that loan that we actually, in the first place, putting out. So, totally agree. Yeah.
One thing that we do when we look at a site is often go, if there's other wind farms in the immediate vicinity, say within 5 kilometers, we will look at the off-gem rock register to determine what the production for that site has been. We know how many turbines there are there. We know the capacity of the turbines, we know the power curve of the turbines, and we can sort of back into the wind speed, making some assumptions about availability for that site. And if we have one site 5 kilometers away and one site 3 kilometers away, we'll take that data, and it's not a reliable indicator for our site, but it's more data. And if there's an anomaly, we'll investigate it. Because if this wind farm 3 kilometers down the road is producing at a level that indicates the wind is much less than we think it is, we need to get to the bottom of that. So I think you can almost never have too much data, too many data points when you're analyzing these investments.
And that's exactly what we do with we've got 13 members on our technical panel, independent technical panel members, to support the training that we've done, and those independent panel members actually use close by sites, close proximity sites, and pull together lots of different sources to actually enable us to be comfortable with the actual kind of speed and returns of that particular project.
You even look at the trees on site. If they're all bending over, you say this must be windy.
Typical farmer says that.
So there is a lot of site specific. A site survey is also important. Everything's important. I think that certainly in my sector, which is sort of wind farms in the 5 to 20 megawatt range, the combination of the virtual Mast technology with on-site measurement gives us an opportunity to really significantly improve our forecasts of wind speed, which, as I've said, is the most important variable in our financial analysis.
The one top tip I'd give to any customer thinking of investing in a wind project is to the fundamental key question for me would be, what source of data have you used to pinpoint your wind speed on the site that you actually put your turbine on? Because I think that's the key question that I'm asking my managers to ask now, and in turn hopefully the message will disseminate down into the industry that wind speed data speed is the most key element of when you're looking at a financial project, the return.
I think for the medium wind industry, Stephen, the virtual Mast gives us a cost-effective, time-efficient solution with greater accuracy, and most importantly, a consistent methodology that meets the international standards for large wind turbines.
A couple of exciting areas that we're researching and developing onto the virtual Mast. One, just to pick up the point that Charles is making, we're looking forward now, not back, at the impact of future climate, not change, which you measure in perhaps hundreds of years, but the climate variability that might impact winds over the next 10, 20, 30 years over the lifetime of a typical wind asset. That's ongoing work, and we'll start overlaying the projections we make currently with that future intelligence, if you like, about the future of wind, as and when we realise the research that we're currently undertaking. And the second point is that we're also launching a version of virtual Mast called Virtual Mast High Resolution, which is actually designed to be used over more complex sites, actually without the aid of a mast, which actually uses a parallel process to generate its own site data. And use that 3 months or a month's worth of site data to correct the long term in the same way that you would use real site data. That's particularly designed to work in complex territories where you might, in some cases, have to take some business decisions without having to put up, to put up real masts. It's early days just at the minute, but the results are encouraging, and with our overall objective of increasing accuracy, that's one very important solution we've got in the sidelines as well.